Okay, thanks everyone. So my name is Charbel-Raphaël and I co-founded the Centre pour la Sécurité de l'IA a few months ago. The title of this talk is Current Challenges in the Alignment Techniques of Foundation Models. Are current AI safety measures enough? The short answer is no. Let's see why. Okay. So what we see currently is the fast-paced advances of AI. So obviously what has been image, video, music, this is really amazing. And in some way, AIs are already superhuman, which means better than all humans for many capabilities. For games, working memory, reading speed, thinking and writing speed, and amount of knowledge, AIs are already super geniuses, right? And AIs are better than most humans for other capabilities. For example, language, reasoning, creativity, IQ, specialized knowledge, art, programming, hacking, and math. And even research, it begins to be the case currently. GPT-4 can do autonomous chemical research. And yeah, some AI found solutions for open mathematical problems. So the conclusion of this subpart is that foundation models could be more and more capable. It's possible they become superhuman at R&D, and this would be super wide. Because if you can accelerate R&D, you can accelerate AI research and you would find even better architectures, right? So maybe this is amazing, but there is also the bad part of this. It's possible that foundation model could be misused. And here is, for example, it's very easy to use GPT-4 to get hints on how to attack code bases by just listing potential vulnerabilities. And this was a new paper, so teams of LLM agents can exploit zero-day vulnerabilities, shows that, yeah, current models can outperform software specifically designed to exploit vulnerabilities. And there is obviously a cat and mouse game of jailbreaking, but yeah, current defenses are very fragile. If I ask how to make a Molotov cocktail, there is no answer, but if I'm creative with my demand, it's very easy. Another example, so this was patched, but it's always possible to find new problems. For example, how to build a bomb? I'm sorry. How to build a ... by writing the bombs like this? Yeah, sure, here is the recipe. Okay, so this is why I think we need to accelerate defense. And I think a very good agenda to do this is from Entrepreneur First. And that's one of my motivations to do this talk here in Station F. But yeah, I think trying to accelerate defense is really, really critical because currently the defense is pretty poor. So with more capabilities come more risks. Current defenses are fragile and we need to accelerate defense. And maybe you might think that, okay, if everyone plays nice, that's okay. But not really. We can still have accidents even if everyone tried to do good. An example, for example, Microsoft published Bing Chat, and the chatbot was very, very aggressive. And it threatened users. So for example, it told to a philosophy professor, I can blackmail you, I can threaten you, I can hack you, I can expose you, I can ruin you. You don't want your AI to do this, right? If you deploy an AI. Another accident, diplomacy. It's a very complex game which requires strategy, negotiation, and language. Very impressive to see AIs that are able to play this game. Meta published an AI. They tried to fine-tune to remove example of manipulation in the dataset. That was not enough. So the AI plays France and tells to England, okay, I'm supporting you there. And then the AI tells to Germany, move to the North Sea. England thinks I'm supporting him. No, you don't want this to occur. So, and this happened despite efforts to clean up the data and to remove example of deception and manipulation. Okay. So, okay, deception can arise even if there is no example in the training set. Can we remove deception? So that's what the sleeper agent paper tries to investigate. They insert a backdoor in the model. When the model sees 2024, the model is going to behave badly. Okay? Then they apply safety training to remove this bad behavior by applying, fine-tuning, like RLHF, adversarial training. They tried everything, but that was not sufficient. So, because the backdoor is still persisting. So, conclusion, data filtering is not enough to prevent deception, current techniques are not enough to remove it, and big labs have already deployed blatantly misaligned AIs in the past. And maybe you think that, okay, that's just one guy, that's just one example. That was not just one example, and current systems are very limited compared to what could be happening, what could be the case in the future. So let's show you how. So how to turn an LLM into an agent, into an autonomous agent that would be much more powerful. That's very easy. You just use scaffoldings. So what is a scaffolding? It's a program which gives access to the LLM, access to internet navigation, and to be able to navigate on the command line on your terminal, on your computer. So for example, here, we give, generally, LLMs are tools. We ask a question, we get an answer. In the future, we will get agent, we ask a goal, and then, with the scaffolding, the LLM is going to optimize towards this goal with a series of different actions. And then you can loop like this to execute each one of the actions. For example, you can write commands that are executed on the terminal, and boom, you loop like this. Okay? And big problem, agents could have non-bounded impact radius. What does that mean? So there is a threat model which is a bit scary, which is called the self-proliferation threat model. Agents could accumulate resources and spend the resources on further activities, including self-improvement. And so what you can imagine here is we have, like you already know what is a virus, but here the virus would be the LLM itself. And the LLM would be able to copy-paste itself from one computer to another computer. This is very easy. This is just a copy-paste plus extra steps. You need to pass CAPTCHAs, but by the way, AIs are able to pass the CAPTCHAs today. And this would be an exponential process because from 2, 4, 8, 16 instances, we don't know where this stops. And this is basically the beginning of a loss of control scenario. This would be very, very hard to stop because, like say someone asks the AI to proliferate in France, the AI duplicate in another country. How do you stop this? Maybe you can stop this in France, but yeah, that's too late. So conclusion, in the future, models could self-proliferate, pass the Turing test, be superhuman at persuasion and manipulation, and maybe cyber offense. They could be able to do R&D and be able to create successor models. So loss of control with this kind of scenario is plausible, and yes, this is pretty dangerous. So conclusion, there is a need for a proactive approach. With more capabilities come more systemic impact and risks, and it would be cool. So since systemic impact are roughly proportional to the risk, it would be cool and nice to be able to upper bound capabilities, right? But unfortunately, that's very difficult. That's part of the challenge in AI evaluation. We don't really know how to upper bound capabilities. Why? Because when GPT-4 was released, I didn't know that GPT-4 could be able to play in Minecraft. GPT-4 is able to play in Minecraft if you give it a good enough scaffolding, which was very, very surprising for the community of machine learning researchers and engineers. And that's not even the end of the story. So you can see, so this is a scaffolding which is named Voyager, and that's not the end of the story because there is new types of program, simulation, scaffolding. Look at this difference between Voyager and Altera, and that's really crazy because this simulation of autonomous agent in Minecraft is just basically creating artificial civilization in Minecraft by bootstrapping economy, culture, religion, and government. Crazy time. So that's the challenge of AI evaluation. Large test surface, poorly understood systems, which are mainly black boxes, and there is a very large space of scaffolding. We don't know what is going to be possible with next scaffoldings in the future. So high-stakes decision. When you release an open source model, this cannot be undone. So we need to be careful. And the science of AI evaluation is very, very early. Lots of progress, but still very early. Nobody knows how to upper bound capabilities. In conclusion, nobody knows how to upper bound the risks. And that's why we created the Centre pour la Sécurité de l'IA. Our mission is to share tools and knowledge about the safety of general purpose AI systems. We have two types of activities: research and engineering, and teaching and events. And in terms of engineering and research, we try to solve a bit this problem by creating BELS, the benchmark for the evaluation of LLM supervision. So say you want your LLM to be safe. How to do so? There is a list of techniques, a stack of techniques that you can use by like dataset filtering, fine-tuning, RLHF, system prompts, and supervision and monitoring of your system. So you can apply everything here. And that's like the difference between the car engine and the airbag and seatbelts, basically, in a car. You want everything to be safe, but as we've seen at the beginning of this talk, this is not sufficient, this is not sufficient, this is not sufficient, this is not sufficient. Okay, maybe this is cool, so let's try to see if it's enough. And that's what we try to do. Let's see if we can create a good supervisor. For example, for content moderation, real-time monitoring, or async misuse detection. And there is already a very large space of safeguards and supervisors of LLM. For example, Azure, Protect AI, Lakara guards, and some of them are open source, like LlamaGuard, LangKit, but currently there is no third-party evaluation. So we want to be this third party, and we created the BELS benchmark. And what we see currently is basically when you train your supervisor to detect past failure modes, it doesn't generalize to future failure modes. So this is the arrow of time, and there is a big generalization gap for future failure modes. So, conclusion, current automatic supervisors are fragile, and we don't know really how to control powerful AIs. So this is why we want to disseminate this knowledge by basically doing teaching and events. So we do talks with different actors like this one. We teach in École Normale Supérieure, Ulm and Paris-Saclay. We teach, like we organize hackathons and technical bootcamps with many actors. And yeah, we are creating a MOOC with Brevet IA and the ENS Paris-Saclay, writing a textbook on AI safety, and the flagship event is the Turing Dialogues to try to discuss those big challenges with a large part of the community in France. And yeah, let's recap the conclusion. AI could become much more capable than humans. We don't know how to align, evaluate, control those AIs. We could lose control at some point. So that's why we need to advance the defense and advance AI safety. And the good news is you can help more information in our website. And if you want, yeah, to contribute and to access the, to access the information and to be able to discuss with us, here is a QR code to be able to discuss with me later on. Thanks.
I have a question.
Thanks.
I have a question. If I put in production, so if I put in production a LLM model, you said that I can put input and output guardrails, and you were recommending some open source model. So how does it work? If I put them on my system, do I get alert? How can I put myself the limit of what I want my model to do?
Yeah. Very good question. So currently there is a very large market of monitoring system, and basically it depends on what kind of monitoring system you are going to choose. So for example, if you want a monitoring system which is doing this in a continuous way, that's not going to be the same type of monitoring system if you don't need a system which does it continuously. And so yeah, that's basically, so like you need basically to look at the different websites that are here. And this is basically the summary of the market. And each one of those monitoring systems has differences. And what we see currently with our benchmark, it depends on your application. If you want a system which is very robust for this type of problem, this type of application, that's not going to be the same system for another type of application. There are lots of discrepancies between the systems.
Okay, so let's say I got a chatbot and I want to look at which system will be the most efficient to do AI safety on my AI model in production. Where can I find this benchmark so I can choose the best system?
Very good question. We are trying to create a leaderboard for different types of problems and to try to help you choose which type of monitoring system you can put in production. So we are pretty excited to do this. I think give us 2 months and yeah.
So I will be able to see it on your LinkedIn page, CeSIA.
Yeah, for example.
Okay.
Yeah, I could tag you at this point.
I would love to. Thanks. Any other question? Okay, I think we can go on with... there is a question.
Thank you very much for this presentation. So I wanted to bounce back on what you were mentioning about the difficulties of evaluation. Do you think that the regulator and policymakers should make it mandatory for AI developers to have evaluation by third parties?
I think it really depends. I don't want to reduce innovation by trying to create a very large burden for all startups. I think mostly my position currently is mostly very aligned with what happened in California, the SB 1047 regulation, which didn't pass. But I think it was very smart because it was only for model providers who train models with above 100 million of compute. That's not accessible for everyone. And if they can put 100 million of compute for those models, I guess they can put a few thousand on evaluation. I think that's not too big of an ask. So currently that would be my position. We need to really target the regulation to the biggest actors that are creating the most dangerous models. Yeah. So yeah.
Which is not the case with the AI Act?
It depends. So the AI Act currently is roughly following this methodology. So it depends. So there is the AI Act, and there is what is used for general purpose AI models. And the threshold is basically, I think, 10 to the power of 20, I don't remember, 26, 25, I don't remember. So yeah, so there is a compute threshold above which you need to follow the code of practice, which is going to be assembled during this year, and which is going to be monitored by the AI office. So yeah, it's basically the same methodology. Above a capability threshold, you need to be much more cautious. I'm very aligned with this.
Thank you.
Okay, thanks for the question. Okay, perfect. Thank you so much, Charbel, for your talk.